Okay, so question 7. What volume of nitrogen will react completely with 29.2 liters of hydrogen to produce NH3 at 477 Kelvin and 645 millimeters of mercury? So first, we just need to write out the reaction that takes place. We have nitrogen, say gas, plus hydrogen gas produces NH3 gas. Okay, so now let's balance out the reaction. You'll see that we have 2 nitrogens on our reactant side, so I'm going to put a coefficient of 2 in front of NH3. So now we have 6 hydrogens on our product side, so I just need to put a coefficient of 3 in front of my hydrogen. Okay, so the question gives us pressure and temperature. I'm going to write them down just for the sake of writing it down. Pressure and the temperature. And they give us the volume of hydrogen, which is 29.2 liters. And we are looking for the volume of nitrogen, which is question mark liters. Okay, so to answer this question, it helps if we know the formula for an ideal gas equation. So the equation for an ideal gas is PV is equal to nRT. Okay, so if you see that the temperature and the pressure are both constant for nitrogen and hydrogen, we can kind of combine them all with R since it is also a constant. So let's put let's rearrange the equation. So let's say we had volume is equal to nRT over P. Temperature and pressure is the same, and same with the gas constant. So we can kind of combine all of those variables, kind of make it equal to K. And then we can write out 2 formulas where the volume of H2 is equal to the number of moles of H2 times K. And then we can do the same thing for nitrogen. The volume of nitrogen is equal to the number of moles of nitrogen times K. Okay, so if we make K equal to each other, so this is reaction 1, and then this is 2. So now we have 2 equations and 1 unknown. So let's just simplify and isolate K and then make the 2 equations equal to each other. So to show this, these will be combined, and then we can write that the volume of H2 over NH2 is equal to the volume of N2 over the number of moles of N2. Okay, so let's make it so that our number of moles are on the same side. So we can rearrange this equation and get number of moles of H2 over number of moles of N2 and be equal to the volume of H2 over the volume of N2. Okay, so just some rearranging of the equation. And now we can kind of plug in everything that we know. We know that 3 moles of H2 is needed to react with 1 mole of N2. And we know the volume of H2 is 29.2 liters. And the volume of N2 is unknown. So if we just divided 29.2 divided by 3, this gives us the volume, which is 9.733 liters. Okay, so let's see what the junior tutor said. Write the balanced chemical equation of the problem. So N2 is equal to, N2 plus 3H2 makes 2 NH3. 2, the volume of nitrogen gas is produced of the, so the volume of nitrogen gas is produced, and is measured under the same pressure and temperature conditions as the hydrogen gas. So this relationship then exists. 1 liter of nitrogen gas reacts completely with 3 liters of hydrogen gas. And then they just simplified and showed how they also got 9.733 liters. Okay, so this solution is correct.